We're going to spend a little bit of time, not very much time, but a little bit of time reviewing lines. The first thing we need to know about is the symbol for delta. If a particle moves from one point to the next point, the first x comma y to the second x comma y, then the increments in its coordinates are the difference between the two x coordinates and the difference between the two y coordinates. And we express difference as delta. And delta, remember, the symbol delta stands for change. So the increments from one coordinate to the next would be the change in x and the change in y. So if we let 2 points, point 1 and point 2, be points on a non-vertical line, then we say that the slope of this line, which we'll call it L, is symbolized by m, and it's the rise over the run. It is also the delta y divided by the delta x, which stands for the change in y divided by the change in x. And then that's where we get our slope formula. The slope formula, y2 minus y1 divided by x2 minus x1, we'll call from today to the end of time the difference quotient. Notice it's a quotient because we're dividing and there's a difference between the two x's and the difference between the two y's. So we review that a line that has a positive slope increases from left to right, increases. So if we're reading a graph from left to right, we say that a line that has a positive slope, we say that it increases. We don't say it goes up anymore, we say it increases. And a line that has a negative slope, we say decreases from left to right. If the line is horizontal, we know that the slope is 0. And if the line is vertical, then we know that the slope is undefined or that it doesn't have a slope. Very important for us to remember about slope in calculus this year. So we know that non-vertical lines that are not vertical, are parallel if they have the same slope. Parallel lines have the same slope. So that's saying that if two lines are parallel, then they have the same slope. And the converse of this is also true. What does the converse mean again? It means that if we switch the statement, it is also true. So if two lines are parallel, then they have the same slope. If two lines have the same slope, then they are parallel. So the converse would be if two lines have the same slope, those lines are parallel. And if two non-vertical lines are perpendicular, then their slopes are negative reciprocals. What does that mean? Negative reciprocal. The negative reciprocal means opposite sign and flip the fraction. We remember that. That perpendicular lines have slopes that are negative reciprocals. Okay, so we can look at this example. What is the equation of the vertical line that passes through 2, 3? The vertical line that passes through 2, 3. So we recall that a vertical line is, a line, normally the equation of a line is normally y equals mx plus b, but we remember that a horizontal line is just a y equals a number, and that a vertical line is just an x equals a number. So the vertical line that passes through the point 2, 3 is just x equals 2. And I knew it was 2 because it passes through 2, 3 that has an x coordinate of 2. Also, what is the equation of the horizontal line that passes through 2, 3? That would be a y equals 3. And then we can find the equation of the line in point slope form, and we will not do slope intercept for that one. We'll just do point slope. Point slope. So it's very important that we remember point slope form of a line, y minus y1 equals m times x minus x1. Do we notice that that formula comes from the formula for slope? M is equal to y2 minus y1 over x2 minus x1. So point slope form, a line that passes through 2, 3 and has a slope of negative 3 over 2. So that would be y minus 3 equals negative 3 over 2 times x minus 2, and that's point slope form. And most of the time in calculus, point slope form is just fine. No need to rewrite that equation in any other form unless we're dealing with a multiple choice question. So point slope form is definitely something that we want to get used to writing. Slope intercept is good also. What is the slope intercept equation for the line that passes through -2, -1 and 3, 4? So the first thing we have to do is find our slope. So I'm going to do 4 minus -1, careful with your signs, over 3 minus -2. 4 minus -1 is 5, 3 minus -2 is also 5. So the slope is 1, and so I'm going to put it in point slope form first. Y minus 4 equals 1 times x minus 3, and then I'm going to distribute my 1, and I'm going to add 4 to both sides. Y equals x plus, y equals not 7, y equals -3 plus 4 is 1. There we go. Okay, so two very important things we have to remember is how do we write the equation of a line in point slope form, and how do we write the equation of a line in slope intercept form. Standard form is also called general form. So we recall that standard form is ax plus by is equal to c. We don't see standard form too much, but we see it in multiple choice questions quite a bit. So we need to be able to recognize that ax plus by is equal to c is also the equation of a line. And another little tidbit that's in this lesson is finding curve to fit the data is called regression analysis. I don't think we need to know too much about that. But one important thing that we do need to know about is the whole idea of proportionality. If y is directly proportional to x, then there is a non-zero constant k such that y is equal to k times x, where k is called the constant of proportionality. So I want you to notice that it says if y is directly proportional to x, then y is equal to k times x. Now we recognize y is equal to k times x as what we call a direct variation equation. We also know it as y is directly proportional to x. So we're going to see problems in calculus this year where it says one thing is directly proportional to the other. And we're going to be required to know that if one thing is directly proportional to another, then y is equal to k times x. It's talking about direct variation. So that's just something that we need to remember. And then lastly, we're going to look at this example. I give you the equation of a line here. F of t, or y, is equal to 130 plus 2t. Let this be the height in inches of the men's winning pole vault, where t is in years since 1900. T is in years since 1900. So year 0 would be 1900. So we're going to make a table for t, which is in years since 1900, and f of t, or y, which is in inches. And in 1900, which would be year 0, let's see, if we plug in 0, that would be year 0, 1900, 1904, 1908, and 1912. So that would be year 0, year 4, year 8, and year 12. So if I plug in 0 into my equation, 130 plus 2 times 0 would be 130. 130 plus 2 times 4, that would be 138. 130 plus 2 times 8 would be 146. And 130 plus 2 times 12 would be 154. Okay, so that's the first thing. We made a table. Then the next question is, what is the slope? Show the difference quotient. Okay, so remember, difference quotient is y2 minus y1 over x2 minus x1. And in this case, we're going to write f of 8 minus f of 0. Let's do f of 4. F of 8 minus f of 4. Doesn't matter in this case. We've got a linear situation, so it doesn't matter which 2 points we pick, right? Having trouble with my pen. F of 8 minus f of 4 over 8 minus 4. So this is my difference quotient here. The difference and a quotient. So we've got 146 minus 138 over 4, which is 8 over 4, which is 2. So in this case, my units for my slope are, we've got 2 inches per year. 2 inches per year. So the next question says, what does the 130 represent? 130 represents the initial height of winning pole vault. And the initial in this case would be in 1900. And in this, is this a decreasing function? Decreasing would mean that the height is going down. So is this a decreasing function? We're going to say no, f of t is increasing, and we can see that in our table, can't we? And the last question is the height directly proportional to the year? How do you know? So we're going to say the height is not directly proportional to the year because f of t is equal to 2t plus 130. And if the height was directly proportional to the year, then it would just be f of t is equal to 2 times t. Y is equal to kx.